Hello, I'm Steve Goff with Little River Research and Design. This short video will guide you through the initial setup and use of our instrumentation and control package for Emriver geomodels. Our small group in Southern Illinois has devoted thousands of hours of R&D to the development of these instruments, some of which are the first of their kind anywhere. These controls, combined with our Emriver geomodel, will enable a wide array of demonstrations and experiments, enabling unprecedented research and teaching possibilities. In particular, the media feeders that are able to precisely meter our unique coated by size plastic sand are like nothing ever built. We look forward to seeing what you do with this powerful equipment. First, we'll look at connector standards. The motors, microprocessors, and pumps are powered by small DC power bricks like this one. We use a system of connectors to make sure things don't get cross-connected. This is the groundwater control unit, for example. The left-hand connector is a black and red connector. In the middle we have a connector for the paddle wheel sensor that has 3 wires. We use a black and red standard for 12-volt DC input. And this unique color code is for the paddle wheel sensor that measures flow. The orange and gray is our standard for 12-volt DC output. The microprocessors are Arduino based, and all these boxes have standard USB outputs for that. Next we'll look at media feeders. The media feeders sit at the upper end of the Emriver model on an aluminum rack. Each one is independent and has a small slot that it fits into. The rack simply sits on the extrusion at the upper end. The individual feeders are simply placed into the rack as you see here. The connectors are yellow and black, which is our standard for 24 volts DC input, which is what the stepper motors in these feeders use. The controls are mostly self-explanatory. The feeders work by simply moving a cone valve up and down with a stepper motor. There's a manifold below the rack array that directs all the outputs down into a mixer that we'll talk about later that essentially mixes the media with water. The manifold simply sits on a set of studs on the feeders at the opposite ends of the rack. A little tricky to put on, but once you get it on, it's great. Here's another shot of the bare rack at the upper end of the model with the toppers removed. The electronic controllers for the media feeders are held by a RAM ball and socket joint that allows you to adjust them to face any direction that suits you. Here we see the rocker arm connected to a small stepper that controls the cone valve. Don't be afraid to manipulate this by hand. And then finally there's a cover there in the storage position, and now it's being put on the bottom of the hopper where it will prevent the media from falling out when the system's not energized. Next we have the groundwater system. It begins with a couple of filters attached to a hose that runs to a diaphragm pump. We have another filter there. These can all be easily maintained by screwing them off. The pump, and then a small air reservoir that dampens pulsations from that pump. Now we have up to 60 psi and a high pressure hose, a small pressure gauge, and then a paddle wheel flow meter that tells you how much is going into the system. And of course the electronic controller controls all this. After the paddle wheel we have a spray bar. What we do is we use high pressure to make sure the flow is evenly distributed across the model, and 4 small sprayers. This system uses a 12 volts DC and as we saw before, hooks up thusly, with the central connector being the paddle wheel flow meter. There are a couple of small brackets you can put anywhere on the 80/20 extrusion that surrounds the model that hold the spray bar. Another component of the system is 2 filters at the bottom that are attached to valves, and they enable you to selectively draw off groundwater. Next, we have the main flow control and magnetic flow meter system. It hooks up very much like the groundwater controller. The sensor, of course, has different colors. Here's the small electronic controller. We'll talk about it a little later, but it's a variant of our Alex controller. This system has a pump. It's where the flow begins, which supplies a 3/4 inch tube that goes up to the mag meter. The yellow unit is the mag meter. The system is sloped so that bubbles will travel through because it's sensitive to bubbles. That tube simply connects to the outlet in your model. And you see there the media mixer as well. When you initially start the system, be sure to get all the bubbles out. It helps to jostle it a little bit, and it just sits on this rack on top so you can shake the whole thing. There are more video and instructions on how to use the Alex flow controller at Emriver.com. One important note on this controller: when you turn the knob when you're in the free run mode, you increase or decrease the pulse width modulation or power to the pump, which increases or decreases flow. And the mag meter will sense this flow, but there will always be some lag between turning the knob and the mag meter response. It's not a closed loop system. Next, we'll look at the dye injector and media mixer. The dye injector is a simple system, but it's incredibly powerful for real-time flow visualization and also to inject pulses at certain periods for time-lapse work. There's an output with a small bracket to hold the output. Simply press the knob on the controller and follow the directions. You can set various combinations of green and blue dye pulses with various combinations of delays between them and pulse lengths. You can also initiate manual pulses by simply pressing the large blue or green button anytime. It's best to situate the output in the movable bracket into the media mixer as shown here. The injector has 2 reservoirs. Simply remove the caps and fill these. The media mixer is an important part that goes over your outflow filter and sits flush flat with the bed of the model. What it does is catch the media and the dye and make sure the media is wetted by the output flow. These output filters are not precisely machined, so if it doesn't fit over the filter, use the provided deburring tool to simply take a little plastic off the inside of this hole so that it does fit over the filter. You can seal this so it doesn't leak, but it's really not necessary. It's better to have it removable and also so you can swing it around a little bit. There will be some leakage through the hole, but it's not important. There is also a movable output funnel in the media manifold. We like to use 80/20 extrusion because it's very versatile and allows easy connection of cabling and other accessories. We provided some various parts for this. One is these little clip-in plastic zip tie holders that are very useful for routing cables. You also will use little drop nuts. They're a little bit tricky to put in, but this shows the basic procedure. And in this case, we're going to attach the dye injector outlet bracket to this one. A little fussy to get into the groove, but very, very handy for attaching any sort of gear anywhere on the model. And finally, if you have questions, comments, need help, please contact us by telephone or at Emriver.com. We're always available during regular business hours to help.